What is actually an environment? It is a collection of symbol comma value pairs, that is x is a symbol and 3.14 might be its value. For example, in this example, z is the variable and phi is z is the symbol and phi is the value assigned to it. So this will be assigned to the global environment. So every environment, it will have a parent environment. It is possible for an environment to have multiple children. For example, every environment that will created in the R package will possibly have the global environment as their mother package, parent environment. The only environment without a parent is the empty environment, which doesn't have any symbols or values associated with it. A function plus an environment is equal to a closure or a function closure. So this is called as the completeness of the function. A function plus an environment will give you the function closure. So how does the value of a free variable is searched? Here I declared z equal to 5. How does this getting searched and brought into the function? So if the value of a symbol is not found in the environment in which the function was defined, then the search is continued in the parent environment. So the value of z is actually searched inside the function or where it is being called for, but there is no assignment to z within the function, so it is searched in the parent environment, which is the global environment package. So then the search is continued to the parent environment. The search continues down the sequence of a parent environment until we hit the top level environment. This is usually the global environment workspace or the namespace of a package. So when I have declared z equal to 5 and use this function, what if a variable is not at all declared or within any kind of environment variable? Then it will return an error saying that variable is not available elsewhere. So after the top level environment, the search continues down the search list until we hit the empty environment. Once the search reaches the empty environment, there you will decide that the variable is not available. So if a value for a given symbol cannot be found once the empty environment is arrived at, then you will get an error saying that the value is not available, that the symbol is not available exactly. Yeah. So why does this matter? Typically, a function is defined in the global environment so that the values of free variables are just found in the user's workspace. Again, this behavior is logical for most people, and it is usually the best thing or the right thing to do. However, in R programming, you can have functions defined inside other functions. They're like in C++, you have like you can the main function contains other functions. That is the only thing that can happen. But in R programming, you can have any number of functions within any function. So C doesn't allow you to do this. Now things start get a little interesting. In this case, the environment in which a function is defined is the body of another function. So for example, if I have a function A and I define the function B within the function A, uh, so it is the body of another function. So you're defining a function within the body of function A. So that's where things get a little interesting. So I have a function make.power where I have assigned function of n. Within that, I create one more function which is just nothing but power. POW equal to function of x, and within that function you just raise x power n. So and you return pow. What is the value of pow you return? For example, we'll see the example. We'll put this example in our module. Control L. I'm clearing the screen. Make dot power is a function I'm defining, which will have a function of n. So again, in this function, I'm defining one more function, which is pow, which is a function of x, and within that, I'm raising x to the power n, and I'm closing the power function, and I'm just throwing out the function, and this is completed. So this function is completed now. So I want to calculate a cube, so I'm assigning this cube to make dot power of 3. So if I use cube of 3, give me 27. So there are two values x comma x passed in, x comma n, x is equal to 3, n equal to 3. So that's the reason you're getting functions. So this is where lexical scoping comes into play, and exploring a function closure.